Okay, hello everyone in a new video. In this one we are going to explain part 2 of chapter 1, which is the chapter of electrostatics and the first unit of electricity for grade 10 students. Then previously in the first part we have explained that any charge can be decomposed into the elementary charges, and we have done exercise number 1 that discuss an idea related to that and to the deficit and to the excess. Now we're going to complete solving this exercise, or we're gonna start exercise number 2, which is also related to the previous idea, and it's given by given an electrified object A. So here they mentioned that the object is being electrified, so it means that the object A is gonna be positively or negatively charged, and by that it's gonna admit a deficit or an excess amount of electrons. Now they are telling us here to calculate in each of the following cases its electric charge QA, and this is straightforward. But notice that since the object is electrified, then it may be electrified positively or negatively. So the charge QA in value, okay, its value is calculated by N multiplied by E, but it may be positive or negative, and this depends on the deficit or on the excess. Now let me start by number 1 and say that here, first of all, so here they told me that this is a deficit amount, so a deficit means that this is a loss. In this case QA is positive. Now let me say that QA is positive, and the reason is given by a deficit. Now in this case, since this is a deficit, then the formula is given by Q multiply, which is given by N multiplied by E. No need to flirt anything, because this is the quantity that we want to calculate. This is QA. Now the number of electrons is given by 1.6 times 10 to the power 9, and the elementary charges is given here, and this is a constant. Now plugging this on the calculator, then the charge of the object A, which is electrified positively, is given by 2.56 times 10 to the power minus 10 coulombs. Now coulombs is the SI unit of charge. This is, so N has no unit, and E is expressed in the SI, which is coulombs, so the value of QA will be in coulombs. Now this is not a convenient unit in the sense that this can be expressed in nanocoulombs, for example, but now the aim of the exercise is just to calculate the value of the charge. Now in number 2, if we refer to number 2, then this is given by an excess. An excess means that the charge is negative, and this is given by an axis. Now in order to reflect this at the level of the equation itself, we're gonna change that. We're gonna say that QA is given by negative N multiplied by E. Now why we have done so here? Because this is negative. In order to reflect that the fact the value of QA is negative, so here there is a minus sign. Now minus the number of electrons gained is given by 2.5 times 10 to the power 12, and the value of the elementary charge is given by 1.6 times 10 to the power minus 19. Now plugging this on the calculator, then the value is given by minus 4 times 10 to the power minus 7 coulombs. And for sure this can be expressed in a more convenient unit, which is the microcoulombs. Now this is in coulombs, then this is expressed in coulombs. Now in number 3, they are telling us that we have an excess of this amount of electrons, and the excess means that QA should be negative because the object has gained electrons, and the number of electrons is greater than the number of protons. Then in this case QA is given by negative N multiplied by E. The negative sign reflects the fact that this is an excess, is equal to minus. Now 3 times 10 to the power 14 multiplied by 1.6 times 10 to the power minus 19, and plugging this on the calculator, eventually the value is given by negative 4.8 times 10 to the power minus 5 coulombs. Now finally number 4, they told us that we have a deficit, and deficit means the charge is positive. Then let's calculate the value of QA given by N multiplied by E. Here we didn't place a minus sign because QA is positive, so we require the answer to be positive. The number of electrons is given by 4.5 times 10 to the power 8 multiplied by 1.6 times 10 to the power minus 19. Plugging this on the calculator, then the value of charge of the object A, which is positively charged, is given by 7.2 times 10 to the power minus 11 coulombs. And here, as a recap for the exercise, so whenever we are calculating a charge which is a deficit, then it's gonna given by Q is equal to NE. Now, if the charge is an excess, then Q is given by minus N multiplied by E. And now let's move to the next section of this chapter, which is classification of materials, conductors versus insulators. Then let me write down. Then this is section number 5. So classification. Oops. So this is conductors versus so we all know that conductors and insulator, here we're discussing about certain property of matter related to how can electrons or the flow of electrons in a certain material. Then let me write and say that mostly materials can be classified as either conductors or insulators. And this depends on how electrons can move, or the passage of electrons through the material itself. And let me say that conductors electrons can move easily. Now some examples on conductors. So we can say for sure that human body is a conductor of electricity. So here we are talking about electricity for sure, because also the property conductor versus insulator can be applied to other aspects. Now a human body is a conductor, and this is simply because we may get electrified or electrocution. So this is a reason why we are conductors. Also, for example, some type of metals that are given by gold, copper, silver, and the list goes on. And some good examples of insulators that we might face later are given by, or let me say that what is meant by insulator. An insulator is where electrons can hardly move or barely move, and some examples on insulators are given by, so like the ebonite. So ebonite is a type of material in which electrons cannot move. It's similar to plastic or close to plastic. Then we can say also plastic. For sure we have the wood, or let me say glass, wood, and the list goes on. And here, so previously I have mentioned this, but let me mention this as a section alone, that in number 6 we're gonna say what is meant by electrification. So electrification is the process in which a material gets electrified, or let me say a material becomes charged. And by that I mean electrified. And now in the coming section we're going to discuss the different methods of electrification. So let me say that section number 7, let me bring this down. And let me say number 7, so methods of electrification. And let's start by the first method, which is the electrification by friction. And this method we face a lot in our daily life. And before we proceed with this experiment, let me name these. Let me say that this is document 1, this is document 2, this is document 3, and this is document 4. So idea number 1. Now here in the first document we're gonna bring two materials. One of them is a glass rod, so this is the glass rod, and another one with this, which is the silk cloth. And now what we're gonna do, as these arrows indicate, we're gonna rub them together at this specific location. Okay, we're gonna rub them for a certain period of time. And let me say that document 1, so this process of rubbing is called friction. Now, not precisely it's called friction, but here friction occurs between the glass rod and the silky cloth. So let me repeat again. So here we are rubbing both objects together. And let me say in document 1 shows two objects of different material that are rubbed against each other. Now, friction, which exists between both objects because they are in contact, let me say that friction causes the objects to get electrified. Now let me repeat again. So what we have done so far, first of all, here we're discussing the methods of electrification, so the processes which allows objects to get electrified. So what we have done, we brought two objects of different materials, one which is the glass rod and another one which is the silk cloth, and we start rubbing them with each other. Then I'm claiming here that both objects will become electrified. Now what is the evidence that they are electrified. Before we talk about the evidence, let me discuss something. Now, idea number 2, electrification by friction. Then let me say that this process is known as electrification by friction, is used to charge insulators. So this method is only used to charge insulators, since electrons hardly move through an insulator. Then they will be localized at the location of friction, and this is shown in document 2. Now here what I'm saying is the following. So first of all, let me repeat from the beginning the main ideas of this section. So we are talking about electrification, and the first method of electrification is the electrification by friction. Now we bring two objects of different materials. One of them is the glass rod, and the other is the silky cloth, and we rub them, and by that one of them is gonna become positive. They're both of them gonna become charged. Okay, so now I know there is a lot of questions that we can put forward, but now in the coming ideas I will try to answer all of these questions. Now the first thing that I'm claiming is that both objects will become charged. Now what is the evidence for that? This will be discussed in document 3 and document 4. But now both objects are electrified. Now the first thing to notice is that this method is known as the electrification method, and this method will be only used to charge insulators and not conductors, and let me explain why. Now since we are rubbing both objects together, then one of them becomes positively charged and the other will become negatively charged. Now, which of the objects will become positively and negatively? This we cannot determine, and this will be discussed later. So now let's suppose that the glass rod is positively charged and this silky cloth is negatively charged. Now the thing is that the charges will only exist here at the place of the rubbing. So we rubbed both objects at this precise location, so charges will only exist at this place. So we don't expect that charges will be here or will be here, because charges along an insulator cannot move easily. So notice that the positive charges and the negative charges are only placed at this specific locations, and I didn't place any positive or negative charge here because of the fact that through insulators electron cannot move. So now, since these are insulators, so the positive charge and the negative charge will be localized here and they can't move. And this method doesn't work for insulators, because if we tried to doesn't work for conductors, sorry, because if we try to electrify by friction conductors, the charge is gonna move easily through the glass rod and the silky cloth if they were classified as insulators, and they can escape easily, for example, through our hands and our body. So we won't find any electric charges through the rod and the silky cloth. Okay, now let me write here trying to electrify conductors using friction is usually hard or challenging, we can say, because electrons can escape easily from a conductor. Now let's talk about the evidence of electrification. Now in this case, what is the evidence that both objects has been electrified? Now notice that in document 3, we try to attract some small pieces of paper. So here we have a table. On the table we have small pieces of paper, and we're gonna use the glass rod which is electrified here, and at this specific location in which these charges are trapped, we're gonna try to attract these small pieces of paper. And the thing is that these papers should be small in order for the electric force which is exerted by the rod to cancel the effect of the weight. So by attracting these small papers, this is an evidence of electrification by friction. Then let me write idea number 3, and this is also happens for the silky cloth. So notice that here also the silky cloth is used to attract these small pieces of paper. Now whether it's positive or negative, both of them are gonna attract the piece of paper, since the piece of papers are neutral, supposed to be neutral. Now let me write idea number 3, the evidence of electrification by friction. Is attracting other bodies. Now these bodies should be light in mass or in weight in order to cancel, since the electric force is gonna be weak compared to the weight in this case. Then 3.1, small pieces of papers can be attracted using the charged rod and this is what is represented in document 3. And similarly in 3.2 we can say that small pieces of papers can be attracted using the charged silk, and this is what appears in document 4. Now in such process of electrification, it's very important to mention that not both will become positively charged, neither negatively charged, but one of them is gonna be positive and one of them gonna be negative. So this rod is gonna have a deficit in electrons, which makes it positively charged, and this one's gonna have an excess of electrons, which gonna make it negatively charged. And the thing is that while rubbing each other, by the process of rubbing, when doing so, electrons will move from the rod to the silky cloth, which makes this positively charged and this is negatively charged. Then let me repeat and say why friction causes these two bodies to get electrified, because whenever we rub them, so friction is gonna occur between both. By that, electrons can escape from the rod or migrate from the rod to the silk, leaving this positively charged and leaving this negatively charged. And let me say section number 4. electrons upon friction. Now here in this case, friction is important in order to extract the electrons since these are insulators. Now in the coming section, we're gonna see that whenever they are conductors, no need to rub. We can just, electrons may migrate upon just touching. Now, electrons upon friction will migrate from the positively charged to the negatively charged object. So let me say the object that loses electrons, and by that it admits a deficit of electrons, will become, so the object will become positively charged and in 4.2 the object that gains electrons it admits an excess of electrons will become negatively charged. Okay. And now let me say section number 5. That we can ask ourselves which of the following object may lose or gain electrons. So this question is a bit difficult, and let me see the direction of migration. And here when I say migration, we're discussing the loss or the gain of electrons between the objects depends on the used material. And this eventually will be given in the exercise itself. Now let me do the following table. Now the materials or the material being used or being rubbed. Let me say that here if we're rubbing silk with glass, so let me say that this is positively charged and this is negatively charged. Now suppose that we are rubbing silk with a glass as we did above. So from this experiment or from document 2 we know that the rod is being positively charged. So let me say that the positively charged is the glass rod. And for sure if one of them is positive the other will be negative. So it's sufficient to know that which one is positive and we can deduce that the other is negative. Now suppose that here in this case we are rubbing fur, which is also a piece of cloth, with ebonite, and ebonite is similar to plastic, and notice that here we are rubbing always insulators with each other because recall that this method only works, or it's convenient for insulators. Then the one which is positively charged is the fur, and the one which is negatively charged, the ebonite. And just let me complete this table by placing the borders. Now, as it seems that the ideas are so complicated, but one cannot judge whether these are complicated or simple unless we solve some exercises. Then exercise number 3, an ebonite rod is rubbed using a piece of fur. So the first thing that we should notice that ebonite and fur are both classified as insulators and not conductors, and this is because we are rubbing them. So the method we're gonna see here, they are telling us that the rod is negatively charged. So the moment that this is negatively charged, then this is positively charged. Now in number 1 they are telling us name the method of electrification involved in this process. As I have mentioned that the ebonite and the fur are insulators, and here because we are using rubbing, the name of the method is electrification by friction. So let me repeat, since we are rubbing, then the rubbing is said to be electrification by friction. Now in number 2 they are telling us, so I was answering number 2 with number 1. Now in number 2 they are telling us, are the ebonite rod and the piece of fur classified as conductors or insulators? Justify. Now because electrification by friction is used for insulators, then the ebonite rod and the fur are insulators. Then let me say, since friction is used to electrify insulators, then they are insulators. Now in number 3 they are asking, can one implement use this method to electrify conductors? Explain. And the answer is no, simply because since electrons can escape, or let me say can easily escape. Now in number 4 they are telling us, specify with the justification the type of charge of the piece of fur. So as we said, that we know that the rod is negatively charged, which makes the fur positively charged. So since the rod is negatively charged, then the fur is positively charged. And finally, in number 5, for both objects, the rod and the piece of fur, specify whether they admit an excess or deficit of electrons. Now, the ebonite rod is negatively charged, which means that it admits an excess. It has an excess, and the reason is given by Q is negative. And for the fur, it has a deficit, and this is because Q is positive. Then that's it for me in this video, guys. In the next part 3, we're gonna introduce some new. First of all, we're gonna solve some exercises related to this topic, and we're gonna proceed with the methods of electrification.